Hello everybody and welcome to your video notes on 8.3, the basic level, which is about Coulomb's law with no algebra. And our goal is to be able to use Coulomb's law to calculate force. Now before I start into examples, we probably should know about what is Coulomb's law. So Coulomb's law is the following. So I'm going to put an equation up here and I want you to copy it down. Alright, so go ahead and copy this down here. So this right here, FES, that stands for, sorry about that. Electrostatic force. And if you remember, force is measured in newtons. Okay, shouldn't be new to you. K is a constant. And that number is always going to be 9 times 10 to the 9th. And then the units are newtons times meters squared over Coulomb squared. That's your constant. R is the distance between the two particles that are in the problem. And this is meters. And I'll sometimes use D instead, because that's like distance, right? Q is the amount of charge. And the reason why it's Q is because for the quantity of charge on the units, those are coulombs, or just a C for short. Okay, so that is our equation for this. So I'm going to do two examples here. I'm going to go ahead and get started with the first. Okay, so this is the question. You can pause and write it down if you would like. But the question just says two charges are at a distance of 5 meters apart. If their charge is that number and that number, what is the force? So we're always going to be using this equation. And then K is always going to be this number right here. So just a reminder on that. So you should always, without a doubt, guess. We're going to start with our givens, an unknown. So for this, we'd have F equals, K equals, Q1 equals, Q2 equals, and then last, of course, R equals. So I do not know the force for this one. K is always going to be that number. Always going to be that. And then Q1 is going to be whichever one. It doesn't matter which one's which, but negative 2.2 times 10 to the negative 7 coulombs. And the other one's going to be a 4.6. Times 10 to the negative 7th. And then R, the distance between them is, say, 5 meters. The equation that one. I'm going to substitute and solve. Okay, so I'm just going to start plugging stuff in. And I'm going to plug it in and then resume when I'm done. Okay, I'm not quite done with everything yet, but all that I did is I substituted these, and now I have to substitute an R, and don't forget that R is squared, so it'll be 5 meters squared like so. Now, the hardest part is typing this in your calculator, so I've got my handy dandy calculator here. Yours is going to look similar, hopefully, but the button that we're going to be looking for is this EE button. We're going to use that to take care of the scientific notation on here. So the EE button is going to take care of that part right there. If you don't have an EE button, you can just type this in normally, but it's going to be easier to make a silly mistake when doing so. So the way I'm going to type this in is 9. Working. Okay, my calculator is working now, so I'm going to do 9E9. Notice I hit the second button so that way I could get to that yellow thing right there. If you don't hit second, it'll just throw a comma on this calculator. But you want to find the EE button on yours. It's probably above the 7. Most of them are. Some calculators will have a button that says like 10x or times 10 and then like a little thing like that. You're going to want to find those buttons and then use those for the scientific notation. So you have 9E9 times, I've got this business right here, so negative 2.2, and then again this is the same thing as the EE, and this is the same thing as the EE. Okay, negative 2.2 EE, negative 7 times 4.6 E, negative 7. And I get negative, oops. Go ahead and do this. I get negative 9.108, and then the E is the same thing as doing times 10 to the power of negative 4, and then that's going to be over 5 squared. I don't need to type that in. That's 25. Okay, so now I'm going to type this in my calculator again, or I could just use this and then do divided by 25. That equal, I get negative 3 times 10, sorry, some decimals there, negative 3 point, I don't know, 64 is good enough, times 10 to the negative 5, and we're looking for force, so it would be newtons. Okay, so I would not like you to write the E for your answer. Please write the times 10 to the power part, and you can also write in scientific or in decimal form if your calculator gives you that. If you're curious about the units, a C times, oh, I forgot to put on there, a C times a C is C squared. I got C squared on the bottom, so those go away. Meters squared and end up squaring the meters there, so I'm just left with newtons. So that's what that's. But don't worry about the units if you're doing your work. Just make sure you got the correct numbers. Okay. Okay, and this is going to be our second problem. I didn't write it out in an English sentence, but it's the same idea. I've got two charges that are separated by a distance, and I gave the charges. Before I go too crazy on this, I do want to talk about this, though. This negative sign is going to tell us that the force is attracting. Another way you can think about it is I've got a negative charge and a positive charge. That's another way you can think about this being attracting. Okay? So this time I've got two positive charges, so we know that they're going to have repelling for our answer. But go ahead and pause and see if you can do this one on your own. Ready, set, go. Okay, and I end up with question mark 9 times 10 to the 9th newtons times meters squared per Coulomb squared, Q1. Doesn't matter which one's which. I'm going to say this one's Q1. 1.6 times 10 to the negative 9th coulombs. Q2 would be 2 times 10 to the negative 5 coulombs, and then R would be 2 meters. Then we're going to have our equation. Make sure you have this written down, but it's just that one. So then we're going to substitute in and solve. Okay, so end up with 9 times 10 to the 9th newtons times meters squared over Coulomb squared times, say 1.6 times 10 to the negative 9th coulombs times 2 times 10 to the negative 5 coulombs. I took that from this guy right there. And then all over 2 meters squared. Okay? I'm going to type that in my calculator again, see if you can get the same thing. Okay, my calculator's working again. 9e, 9 is this first bit right here, times 1.6 e negative 9 times 2 e negative 5. On the top I get 2.88 times 10 to the negative 4, and you could have a decimal for that as well. And then I get 2 squared, which is 4. I'm going to take this number, divide it by 4, and end up with an answer of 7.2 times 10 to the negative 5 newtons, or 0.00072 newtons. Either one will be acceptable. Thanks for listening.